This video will cover Year 9 Algebraic Expressions Fundamentals Test Preview. So these are the sort of questions you should expect at a C level in this topic. I'll put some time tags below for anyone who'd like to skip to question numbers following along on the test preview sheet, and I'll put some descriptions of what sort of questions they are for others who'd like help with something in particular.
Question 1A is a simplification task, so what we're doing is we're collecting like terms. We're allowed to collect a squareds, but they're not to be collected with a's, they're quite different. So we'll collect the a squareds, we can collect the a's together as well, and the little numbers stand alone. So we just simplify. I've got 6a's and I add an additional, 6a squareds and I add an additional 3a squared, so I've got 9a squareds altogether. I've got a debt of 4a's, or negative 4a's, and I add 5. So I've got 1a, and I've got a little negative 3 on the end. In 1b, I'm going to collect like terms again. So I've only got these c squareds, but I've got a couple of c's that I can work with. So the negative c squared comes down. I've got 2 c's, and I take 9 c's away, leaving me with a debt of 7 c's, and I've got a negative 7 on the end. In question 2, we're going to have to simplify these, but we need to solve them first. So BODMaths tells us we've got to multiply before we add, so we'll multiply these together. So 3c times 5m makes 15 cm's. Doesn't matter what order you write the letters in, but it's generally considered good practice to do them in alphabetical order. And I've got 1m times 2c's making 2 cm's altogether. Now I can collect these like terms, so I'll have 17 cm's altogether. 2b, I need to solve first. I'll get rid of that multiplication. So I will carry my 4c squareds down, and then I've got negative 3c's times 3c's, making negative 9c squareds, and 8. And now I'm going to collect up my like terms. So if I've got 4 and I take away 9, I've got negative 5c squareds plus 8. In 3a, I'm going to expand and then simplify where possible. So remember, when you've got brackets, it's this times this, then this times this. If you follow the system, you'll never go wrong. So 4 times 6n makes 24n's. And 4 times negative 2 makes negative 8. 3b, we're going to expand and simplify. So remember, this times this, this times this, okay? The system will always work. This times this, this times this. So let's expand it out. 4 times 3x makes 12x. 4 times negative 5 makes negative 20. Okay, we have to get rid of these brackets too. So remembering that the negative goes with this term, okay? Negative 2 times x makes negative 2x. Negative 2 times 1 makes negative 2, okay? Now I'm going to collect up my like terms. So I have 12x's and I take 2 away, leaving me with 10x's. I have negative 20 and I take 2 away, I have negative 22. Okay, question 4 is using binomials, okay? And these have a little system as well that we always follow. So this times this, then this times this. Then we jump to the second number. This times this, then this times this. If we follow the system, we'll never go wrong. So we've got c times c makes c squared. C times 7 makes 7c. Minus 4 times c makes minus 4c. Minus 4 times 7 makes minus 28. Now we collect our like terms and simplify. So I've got c squared, then I've got 7c's and I take 4 away, leaving me with 3c's, and then I've got negative 28 on the end. 4b is a binomial as well, but just so it's a little clearer, let's just rewrite this. So this is the same as saying m minus 4 times m minus 4. Okay, that way we can follow the same system. M times m times minus 4. Minus 4 times m, minus 4 times minus 4. So, m times m makes m squared. M times minus 4 makes minus 4m. Minus 4 times m makes minus 4m, and minus 4 times minus 4 makes 16. Collect up my like terms, and I'm left with m squared minus 8m plus 16. Question 5 is about finding the highest common factors. Now this is more useful for question 6 when we've got to factorise expressions. But what we're doing is we're going through here and we're trying to find common factors. Now I can see that there's the only common factor of 7 and 9 is 1. Okay, this one's got n's but this one doesn't. This one's got c's and this one's got c's. So we can take c squared out, and that will be our highest common factor. That's the number that can be multiplied into both of those. Question 5b, we can find more interesting or more common factors in these ones. So I'm looking first of all for a factor that goes into 10 that also goes into 15. So I know that 5 is the case. I've got c's here and I've got c's here. So I'm going to take as many as I can. I've got c to the power of 3, that will go into both of those. And I've got a d and a d squared, so I can also take a d. So they will be my highest common factors. In question 6a, we're going to use the skills that we talked about in question 5 about identifying the highest common factors in order to factorise these expressions. So in other words, I want to put brackets in, and I want to take as much outside the brackets as I can, okay? And I'll take the negative if I can too. So first of all, look at the numbers, 2 and 6. I know that 2 will go into both of those, so 2 can come out the front. M is in both terms, so I'll take the m out the front as well. And that leaves me with k and a minus 3 in the brackets, because 2m times k makes 2mk, and 2m times minus 3 makes minus 6m. 6b, we have to factorise, finding the highest common factors like we did in question 5. So let's have a look at the numbers first. I want to ultimately end up with brackets and something outside of them. So look at the numbers. What goes into 4 that also goes into 10? 2 does. Oh, look, there's x's in both expressions, so we'll take x out the front as well. And that leaves us with 2 x's here and negative 5 here, because 2x times 2x makes 4x squared, and 2x times negative 5 makes negative 10x.